All right, good evening. So tonight we're just going to finish up what we didn't get done on Monday. We were talking about confidence intervals, proportions. Okay, so the idea with a proportion is it's a binomial distribution. But when you take a sample size, the standard deviation, so if you recall the variant, or the standard deviation for a binomial is the square root of NPQ. Okay? But when you take a sample size of n, for a sample it becomes this. PQ over n. Okay? Now the thing to remember is if I don't know what P and Q are, like what percent of the population likes strawberry ice cream, I don't know. The best I can hope for is what we call a sample proportion. So I'm going to ask some people, hey, do you like strawberry ice cream? A certain number of people say yes, that's X out of the total. That's a percentage, a proportion, if you will. Q, of course, is 1 minus P. That's all there is. Okay? Again, I don't know going in, do we have, 30%, 40%, 12%? I don't know. So because of this, I have to work at this direction. So the game will be this. Z is equal to, okay, remember you're going to be doing a negative Z is less than or equal to. Now this part you don't need to write down. Just going to watch where it comes from. P hat minus P. P hat Q hat over N. Okay? Now if you were to solve this for P, what you end up with is you end up with P hat plus or minus Z square root of P hat Q hat over N. This is where you hear things like a margin of error plus or minus 3% of the population likes strawberry ice cream or whatever. Okay? So if you went out and sampled, say you sample 500 people, and 200 like strawberry ice cream, that's a P hat of 0.4. Q hat, of course, then is 0.6. Okay, it's that easy. So it's 0.4 plus or minus. Hey, it's a z-score. If I want a 95% confidence interval, it's 1.96. It's that easy as well. 0.4 times 0.6 over 500. Pardon me, I'm kind of catching a cold again. It's great. .04. In other words, it is 40% of the population with a margin of error of plus or minus 4 percentage points. Like strawberry ice cream, or it's the best, or whatever you want to say. Okay? That's it. Excuse me, there isn't a whole lot to it. Okay, so we'll do several other examples of it. But again, the key to remember is I don't know P and Q. Therefore, I'll be, on this problem, I'll be using P hat and Q hat from the sample. Okay, let's do another one. Okay, so you want to know what percent of the population thinks that, whatever. I don't know, just pick your favorite political commentary. This political issue is important or whatever, okay? So you're going to sample 1,000 people. And 430 say, yeah, that's a big deal, or yes, I really like that, or maybe it's your no, I don't know, it doesn't matter to me, I don't care. So that's 0.43. Of course, that means Q is the rest of it. It's that easy. So if I want a 95% confidence interval, and again, that's what we do most of the time, clearly as n gets bigger, our margin of error goes down. That's just common sense. Plus or minus 3 percentage points. In other words, 43% of the population, like this latest thing with a margin of error plus or minus 3 percentage points. Okay. Now, most of the time when you are sampling for this kind of thing, most of the time you want to do plus or minus 3 percentage points. That's kind of the agreed upon. Good news is you really won't do this in your real day life, but this is where they do it. The question then, of course, would be, how big of a sample? How big of a sample do I need to be within 3 percentage points? Okay. And so when you do that, the question is, well, okay, what am I going to have to do? I'm going to have to, what I'm going to have to do is I'm going to have to then increase n, obviously, but your margin of error depends on this guy. Z, of course, that doesn't change. But it depends on P and Q. Oh, dude. But P and Q also depend on n. Oh, for the love of Pete. This is ridiculous, right? Not so fast. We got this, okay? If I don't know going in what P and Q are, you with me? Like, I don't know. Is it 50%? Is it 60%? Is it 12%? Is it whatever? The way we have to do is you have to pick P and Q hat, if you will, so that, because again, we don't know what they are going in. If we're blind going in, so that we make the margin of error as big as possible. Therefore, I guarantee I get the right size in. Okay? So what I mean by that is this. If you were to solve this guy, okay, I need to know what P and Q are. Or I need to have an idea of what they are to be able to solve for n. Because you can only solve for one variable time, obviously. So it turns out that P and Q always add up to 1. So you get 0.5 and 0.5, for instance. 0.64 or 0.6, 0.4, 0.3, 0.7, whatever, right? All those add up to 100%. This pair, when you multiply them, is 0.25. They are the biggest pair that you will ever find. You with me? 0.9 and 0.1, 0.09. That's a small number, okay? So if I have no idea going in, what I'm going to choose then is this on top to be 0.25 when I get done multiplying. Make sense? And of course, this is 1.96, and let's say I want this to be 0.03. Okay, well, obviously do some math here. Gosh, help me. I love a little bit of algebra in the morning. Well, late at night, whenever you're doing your math. And so 0.015, let's flip that. I get 65 is equal to the square root of n over 0.25 as I flip both sides over. Hey, let's square both sides. All right, squared. That's hot. And so you get 4268. 4268.4 is equal to n over 0.25. And if you times by 0.25 to both sides, you will find that you need to sample at least 1,067 people to pull this off. Now, the way you do this, in reality, it becomes Z over E squared P hat Q hat. Okay, whatever this answer is here needs to be, n has to be bigger than or equal to this number. Okay, that's what it always is going to be. Now you're like, well, but what if I took a sample yesterday, Jay? So I asked about, the president's approval rating yesterday, and let's say it was 50% yesterday, or well, that's a bad example. It was 60% yesterday. Well, that's hot diggity. If it was 60% yesterday, then that means down here, then of course, this would be 0.6 times 0.4, which would be 0.24. And what would that do to my confidence interval? It would be 4268 times 0.24 instead of 0.25. And so I wouldn't have to sample as many people. In other words, if I have some pre-existing knowledge going in, like we've been tracking the presidential approval rating or whatever, and I have a pretty good idea of what it is, well, what it was yesterday, so I have a pretty good idea what it is today, then I can probably start with that, and I don't have to go sample as big a population. Okay, so that's kind of typically how that works. Confidence intervals proportions are large numbers. Typically, you're not going to get by with less than 1,000 if you want a 3 percentage point setup. Okay, I mean it's over 1,000 every time. Well, I'm only going to take 800. Well, then you're not going to be within 3 percentage points. You might be within 4 or 5, but you're not going to be within 3. Okay, so we can also do hypothesis tests. Hypothesis tests with proportions, and they're kind of fun. So like Bob, always Bob. I like Bob. Bob's a good guy. Bob believes the percentage of kids who are obese is more than 37%. Just made that up. Just made it up. So what does he do? He takes a sample. He takes a sample of, 600 kids. Nice. And 250 are obese. At alpha equal 0.05. Is he right? Now, this is critical on this one. Don't screw this one up. So H0, H1. Okay, we are told that he believes that P is equal to 0.37. And of course, or he thinks it's greater than 0.37, but that's the idea. We, again, are operating under this assumption. Now, pay attention. This is huge. Z equals P hat minus P. Oh, I'm down with that, Jay. Over, now wait for it, PQ over N. Don't you mean, crap. Don't you mean P hat, Q hat? No, I don't. Because under a hypothesis test, we assume H0 is true. Well, under H0, P is 0.37. And as such, we're going to use that to figure it out. Does that make sense? That's what we're going to use. And so in our case, it's going to be 250 over 600 is 0.4166 minus 0.37 over 0.37 times 0.63 over 600. Okay? Same rules as before. Anything bigger than 2, it's automatic reject, obviously. Minus 0.37 divided by 2.36. Your answer is, hey, you reject right now. Yes? Right now. Of course, pull up your Excel. You can still get a p-value for it, but there's really, it's moot point. I'm going to reject H0. What does that mean? Well, it means Bob's correct, right? Because he said it was not H0. So it's equals norm dot, oops, it was equals, I said. Darn you, you hippie. Equal norm dot s dot dist 2.36, 1. Get ready to slap your head. Oh, poop. Oh, shut up. Oh, no. Escape, escape, escape. Rats. Norm dot s dot dist. Okay, so what I was going to say is get ready to slap your head because Jay messed up. This is upper tail test. Oh, Jay, you big dummy. 1 minus 0.009. As promised, we are rejecting H0. So reject H0. The percentage of obese kids has increased significantly. Okay? Or something along those lines. Or you can say Bob's right. Bob's a freaking genius. Whatever it happens to be. Okay? Susie works for the cops. Susie feels, whatever, that the number of thefts have increased, or not the number, the percentage of arrests for thefts have increased. It used to be 24% of all arrests were for 24% of arrests. Oh, for the love of Pete, of arrests were for theft. Cool. So what does he do? Well, she goes out and samples 1,200 people, or 1,200 arrests, and she finds that 310 are theft. Nice. So at 0.05, alpha's 0.05, is she right? I don't know. Again, and so z equals, now 310 divided by 1,200, that's my p hat. Oh, poop. Nope, it's 1,200. So 25.2583 minus 0.24 over, again, under the null hypothesis, it's those guys. And so if I take that minus 0.24, divide by the square root of 0.24 times 0.76 divided by 1,200, 1.48, z equals 1.48. Now I'm just going to say right now, I don't think that's enough to say, that's it. I don't think so. So I come over here, let's change that to 1.48. Yeah, it's 0.7. It's about 7%. So P is 0.07. So fail to reject. Fail to reject H naught. Again, it's fail to reject or reject. Those are the only two things you can do with H naught. Okay, Susie's wrong. Susie's wrong. The percentage has not increased. Okay, identical. It's an identical thing, okay, from what we did before. There's no difference. The only difference is how we compute our z-score now, okay? We do one more, maybe. Politician wants to know, he's traditionally, he has been sitting at 70% approval rating. Nice work, bud. And so he wants to know if it's changed recently. Because, I don't know, he's getting stuff thrown at him. I don't know. Whatever. Who knows? Okay? Yeah. Has it changed? So what do you do? Well, you take n equals, I don't know, 1,200. And you take x equals... you get 800, 783 bitchin'. Nice. And so again, alpha 0.05 is this, has it changed, right? That's what I want to know. I'm going to die here. Okay, there's that, 0.6525. So if we're doing this at home, your z equals 0.6525 minus 0.7 over 0.7 times 0.3 over 1,200. Minus 0.7 is that. Oops, is that. Oh, you idiot. Minus 0.7. Negative 3.59. Holy buckets. That's instant reject, yes. It has changed, and it has changed significantly, again, because it's outside of 2. However, I do want a p-value for this. So that's way over here, tiny amount over here, but remember you can times it by 2 on a two-tailed test. So equals norm.s.dist negative 3.59 comma 1. And remember, it's a two-tailed test, so times that baby by 2. There's your p-value, 0.003. Reject H naught. The proportion has changed significantly. That's all we asked on a two-tailed test. Has it changed, yay or nay? Okay, we didn't say increase or decrease, just yay or nay. All right, good luck.